Now let's take a look at going back the other way. Notice it's integration involving inverse trig. It's not actually integrating inverse trig. So basically what we're going to look at is the reverse of the differentiation. If our integral is set up like this, we can see dx on root a squared minus x squared, then that must go back to the inverse sine x on a. Of course, now we have a choice. Remember, inverse cos and inverse sine gave us pretty much the same answer. It's just one was positive, one was negative. Which one do you use? Well, it doesn't really matter. The question might dictate which one you're going to use, because one might be easier than the other in the solution, but it doesn't matter. The a squared plus x squared one, well, that one goes to our inverse tan, but again, this was the one that was a little bit different. Remember, inverse sine, inverse cos had 1 on the top, whereas inverse tan had a on the top, and that's why when we go back the other way, we get 1 on a for the inverse tan. Personally, again, these ones, and this is how they're on the reference sheet as well. They do it this way. So the integral, you want to set it up so it has derivative on the square root of a squared minus the function squared. Then we know that goes to inverse sine of that function divided by a, or again you could choose minus inverse cos. And for the inverse tan one, we want to set it up so we've got derivative on a squared plus the function squared, and then we know that that one goes to, but again we've got to be careful with inverse tan, the 1 on a inverse tan function x on a. But again, they are on the reference sheet, so if you're ever unsure, make sure you check and go, yeah, that's right, it goes that way. Okay, then we see this one, dx on the square root of 4 minus x squared. Well, if I remember the a squared minus x squared form, I can go straight to that. I go, oh well, that's inverse sine x on 2. There's our answer. Dx on 9 plus x squared, again it's in that standard form, so that one would be but 1/3 because it's inverse tan, and then x on 3. Let's do a definite integral, dx on the square root of 2 minus x squared. That one becomes inverse sine of x on root 2. These sort of numbers we will see a lot, again because of the exact values. When I substitute in, I get inverse sine of 1 on root 2, it's one of our exact values, minus inverse sine of 0. So we have pi on 4 minus 0, pi on 4. Now, this is where it's really important to remember about radians. It's so tempting to write 45, but it's not 45. It's pi on 4. One of these ones. Differentiate this, hence go and find this integral. So I'm kind of expecting when I differentiate this, I'm going to get something that looks like this integral. It's one of these hidden hints there. You go, okay. Let's see what happens. Differentiate inverse sine. Okay, when we differentiated, that was the derivative over the square root of 1 minus the function squared. Let's write it that way, and oh, what do you know? It does in fact turn out to be the integral. So now, that means if I go back the other way, when I integrate this thing, I must have got the inverse sine of e to the x. Substitute in e to the power of 0, well that's 1. E to the minus log 2. Now I've done it all in one step. But remember, e to the log will cancel. But not e to the minus log, that won't. So I need to bring the minus sign into the log. So it now says e to the log 2 to the power of minus 1. Well, 2 to the power of minus 1 is a half. Bang, I just jumped straight to a half, but that's the thought process to get there. All right, they're both exact values. 1, that goes to pi on 2. A half, that goes to pi on 6. We end up with pi on 3. Dx on the square root of 4 minus 9x squared. I want to put it in the form I'm comfortable with. Derivative on a squared minus the function squared. Now, that means my function's not 9x squared, because remember this is the function squared. My function then is 3x. So I want the derivative of 3x on the top, well that's 3. So I'll put 3 on the top, balance it out, 1/3 out the front. Now it's in our standard form. I know that's going to be the inverse sine of 3x on 2. And 1/3 out the front, of course. Oh, and plus a constant. We can't forget our plus constant. So that's going back the other way. So 12b, we'll look at the integration.